Ever notice how your phone's voice assistant gets you, even when you're shouting over a noisy crowd? Or how a video call still makes sense when the audio glitches? That's not magic. It's AI learning to adapt when information is missing. Today, we're diving into a breakthrough called ADMC, Adaptive Multimodal Contextual Modeling, a smart system that helps AI understand the world even when data is messy, incomplete, or broken. Let's break it down. Here's the core challenge. Modern AI systems often rely on multimodal data, combining audio, video, and text to infer context. But what happens when the microphone dies, the camera freezes, or the text is blurry? Traditional models panic. They either guess randomly or fail entirely. ADMC, however, acts like a detective with a superpower. It doesn't just handle missing clues, it uses what's left to reconstruct the whole story. Here's the technical breakdown. Instead of forcing all modalities, audio, video, text, to speak the same language at once, ADMC trains specialized neural networks for each. Think of it as a team of experts. One analyzes vocal tone, another deciphers facial expressions, and a third interprets textual patterns. These models learn their own unique features without confusion. Then, when data is missing, an attention-based diffusion model steps in. This part is revolutionary. The diffusion model acts like a generative AI that fills in gaps by studying how real-world multimodal data typically looks. It doesn't just guess, it uses the available data to synthesize realistic missing components. For example, if audio is lost, it might infer speech from facial movements and text. It's like solving a puzzle with missing pieces, but the AI knows the full picture should look like. What sets ADMC apart? It's not just about fixing gaps, it enhances performance even with complete data. By analyzing how modalities like voice and text interact, it improves contextual understanding. Imagine a virtual assistant that's not just listening, but listening, watching, and reading, and still functions when one sense fails. The results? ADMC shattered benchmarks on real-world datasets like IEMOCAP, emotion analysis in conversations, and MIntRec, intent detection in TV shows. Even when 50% of data was randomly removed, it maintained 88% of its performance, far superior to existing models. And here's the kicker. It didn't just handle gaps, it made the entire system smarter by reinforcing cross-modal relationships. So why does this matter? Picture a smart home that understands you even if your phone dies, or a mental health app that detects stress from a blurry video call. ADMC is paving the way for AI that's not just powerful, but resilient, capable of adapting to the chaotic, imperfect world we live in. Next time you interact with AI, remember, behind the scenes, models like ADMC are working hard to make sense of the chaos. Because in the end, the goal isn't just to process data, it's to understand us.